In this video, I'm going to go over number 2 from the free response questions. And, make sure, just a reminder again for this class, my 2022, 2023 students, that we're just talking about going over this of what it might look like on the AP exam. The test you're going to take is just the multiple choice. So let's look at number 2. We've got two graphs here, F and G, and it says that the graphs are shown above with the interval with x between 0 and 5, including both 0 and 5. Write a difference quotient that best approximate the instantaneous rate of change of g at x equals 2.5. So my first thought was, if I go to the g graph, and where x is 2.5, looks like it's approximately here when x is 2.5. And what we've talked about is to find the instantaneous rate of change, you want to find the slope of the tangent line to your curve, right, at that point x equals 2.5. Now, the thing about this is that when I look at my curve, I'm using air quotes here, my curve is actually a line. So to find the slope of the tangent line to our curve at this point, x equals 2.5, I can actually just go ahead and use these two endpoints for this little piece and find the slope, and that would give me an approximation for the instantaneous rate of change. All right, so I'm going to write the change in y over the change in x using my points. I'm going to have 2, 4, and 3, 1. So I'm going to write 1 minus 4 over 3 minus 2. All right, so this difference quotient of negative 3 over 1 is going to give me my best approximation for the instantaneous rate of change of this function at this particular x value. All right, so that's it for the first one. Let's go to part B. Part B says we have a function h of x is defined as g of f of x. So that's composition there. Find the value of the limit as x approaches 3 of h of x. So again, I could write it like this, and we talked about this in class, that if you have composition, you can actually do g of the limit as x approaches 3 of f of x, so find that, and then plug it into your g function. Okay, so let's find the limit first as x approaches 3 of f of x. So I'm looking at my f of x function. As I approach 3 from the left, I'm approaching 2, 3 from the right approaching 2, so the limit as x approaches 3 of f of x is 2. All right, again, just to confirm, yes, it is 2. So now, all I need to do is go in and find g of 2, which g of 2, my closed circle, let me erase these now. My closed circle for g of 2 is 4. So after doing all of that, the limit as x approaches 3 of h of x is 4. Okay? All right, let's go to part C. All right, part C says that we have a new function k defined by 4 minus f of x, and then all of that multiplied by g of x. And we're considering two x values, 2 and 4, and we want to see whether k is continuous at each of these values. So when we talked about functions being continuous at certain x values, it has to achieve really two things. The limit as x approaches those values must exist. So we'll show how I'm going to look at approaching those numbers from the left and the right, and they must be the same. So if the limit exists, then you check to see when I plug in 2 into the function, the y value I get, does that match the value for the limit as x approaches that number? And if all of that matches, if all of it's the same, then you know that it is continuous. But if not all of that is the same, then you know there is discontinuity happening. So let's start with just the number 2 here. So I'm going to find the limit as x approaches 2 from the left of k of x. All right, and so the notation I'm going to write is I'm going to write the limit as x approaches 2 from the left of 4, which is really just going to be 4, minus the limit as x approaches 2 from the left of f of x, and all of that's going to be subtracted and then multiplied by the limit as x approaches 2 from the left of g of x. So if I can find all that, then I can figure out what that value is going to be. So again, that's just going to be 4 right? Because the limit as x approaches any number of a constant is the constant. Let's see what the limit as x approaches 2 from the left is for f of x. So 2 from the left is going to be 4. So I'm going to write 4 minus 4. And then this limit as x approaches 2 from the left of the g function, and 2 from the left of the g function is going to be negative 1. So I'm going to write negative 1. All right, so when you do that algebra, you get 0 times negative 1, which is 0. All right, now let's see what happens when I do the same thing, but approaching this 2 from the right. All right, so I'm going to do the same notation. So copy it down, but now I'm just doing 2 from the right. We know that's still going to be 4. And then multiplied by the limit as x approaches 2 from the right of g of x. All right, so I know that's 4. Let's find the limit as x approaches 2 from the right of f of x, which is also 4. That's good. And then I'm going to find the limit as x approaches 2 from the right of g of x, which is 4. Now I know that's different, but you'll notice that with our algebra, because we have 0 in that first parentheses, it actually doesn't matter that the that value for g was different. So 0 times 4 is still 0. So these match. And so what this tells us is that the limit as x approaches 2 of k of x is equal to 0. All right, so now I'm going to plug in k of 0. And if I also get 0 for this, then I know that this is continuous. This function k would be continuous at x equals 2. So let's see what happens. So I do 4 minus f of 0 times g of 0. All right, so that's going to be 4 minus, let's do f of 0, which is 2, and g of 0, which is 1. Make sure I get that right again. F of 0 is 2, and g of 0 is 1. All right, I made a mistake here. You probably already saw it, so sorry if you were shouting at the screen. I plugged in 0, but that's not the number I'm supposed to plug in. The number I'm supposed to plug in is actually that same x value, the first one we're considering, which is 2. So that's my fault. I apologize about that. So I'm going to do 4 minus f of 2, and then times g of 2. I was going to say, like, I did this earlier and got a different answer. So what am I doing? Okay, here we go. So f of 2 is 4, and g of 2 is also 4. So this is going to be 4 minus 4 times 4, which is, again, going to be 0. There we go. That makes more sense. So because the limit as x approaches 2 of k of x is 0, and, so let me kind of highlight this for you. So this limit as x approaches 2 of k of x is 0, and k of 2 is 0, because those are the same, then we say that this function, so let's write k is continuous at x equals 2. All right, and again, that's because the limit as x approaches 2 of this function is 0, and when you plug in 2 to the function, you also get 0. They have to match. Now let's try, I know I kind of left us very little room. Let's go ahead and try, I'll write very small. The same thing, but as we approach 4. So I'm going to approach 4 from the left. And that's of 4 minus the limit as x approaches 4 from the left of f of x times, we're going to approach 4 from the left of g of x. All right, so here we go. The limit as x approaches 4 from the left of f is 3, and then for g is 1. So this is 3, so 4 minus 3 times 1. So 1 times 1 is 1. Let's do the same thing, but approach our 4 from the right. All right, so that's going to be 4 again. This time we'll approach 4 from the right at these two different functions. All right, so it's going to be 4 minus, let's go see what it is for 4 from the right for f of x. It's still 3, and then 4 from the right, though, from g is actually going to be 4. So this is 4 minus 3 times 4. And when you do that, you get 1 times 4, which is 4. So you'll notice that since the limit as x approaches 4 from the left of k of x and the limit as x approaches 4 from the right of k of x are not the same, this limit as x approaches 4 of k of x does not exist. And again, if your limit doesn't exist, then there's no way that it could be continuous. Okay, so I'll put it over here to the right side. The limit as x approaches 4 of k of x does not exist, so not continuous at x equals 4. All right, let's try one more here, this last one, letter D. It says, values of f of x at selected values of x are given in the table below. What type of discontinuity does f of x have at x equal 1? And then based on the tables, or the values in the table, what is a reasonable estimate for the limit as x approaches 1 of f of x? All right, so first thing I would look at here is as we're getting closer and closer to 1, right, we're approaching, if you look here, it looks like we're approaching the same number, getting closer and closer to like 2.78 something. All right, so since we're approaching the same number from the left and the right, the limit is going to exist, okay? But then I look at this main part here, which says when x is 1, you have an undefined value, all right? So that means that because your limit is going to exist as they approach from the left and the right of 1, right, we're going to have a hole at 1 comma this number we're going to find here in a moment. And so that means we're going to have removable discontinuity. So f of x has removable discontinuity at x equals 1. All right, and then in terms of estimating a value, I think the best estimation for the limit as x approaches 1 of f of x is to just look at the y values here. We've got 2.784 and then 2.787. And it looks like we keep getting closer and closer to something that's in between them. So let's just find the average, right? So add them up and divide by 2. And that will give us, what I think is a good estimate of where the limit would actually be. So when you do that, you get 2.7855. Okay, so that's it for this second question. Again, just a reminder to focus on those multiple choice questions, but this is what it could look like on the AP exam for the free response section.